Good afternoon, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
Together, we are Backyard Musings, the Science and Technology channel.
Yeah, and today we're talking about the moon and detecting some water, ice on the moon. So it's kind of fascinating.
And don't forget, if you have time, you have the viewing space, watch that Perseid meteor shower tonight.
Yeah, that's going to be pretty cool. So hopefully you have clear skies and you can get to a place that's dark. So.
All right, here we go. By studying how seismic waves move through frozen soil on Earth, a geophysicist helped develop a more effective method for detecting water ice on the moon. Beneath the moon's permanently shadowed polar craters, water ice may lie hidden beyond the reach of instruments in orbit. Researchers now think those buried deposits could be located by listening for changes in the vibrations traveling through lunar soil. Would you like to know more?
Okay, geologists from the University of Maryland, Lawrence Berkeley National Laboratory, and the University of Hawaii found that seismic waves, the same vibrations recorded during earthquakes, could reveal map ice beneath the lunar surface. Published in Science Advances on July 31st of this year, the findings arrive as NASA prepares to send astronauts towards the moon's south polar region through its Artemis program. We talked about that a bunch, with crewed landings targeted for 2028. Ice preserved inside the deep shadows of polar craters could become one of the most useful local resources available to future explorers.
Once melted and purified, lunar ice could provide drinking water. Electricity could also separate it into oxygen for breathing and hydrogen for rocket fuel, reducing the amount of material that long missions and permanent outposts would need to carry from Earth.
Quote, it's crucial to identify any materials on the moon that an astronaut can make use of while they're up there, says Nicholas Schmer, an associate professor in UMD's Department of Geological, Environmental, and Planetary Sciences, and a co-author of the study. Going on with his quote, since they will be limited by the few resources they brought from Earth, anything they find on the moon will help them basically live off the land, especially for longer-term missions or outposts, unquote.
The amount of distribution of lunar ice remains uncertain. Satellites can examine the moon from orbit, but their observations are largely limited to the shallowest layer of soil. Some deposits may be buried much farther below the surface, where seismic measurements could provide a clearer view.
The principle rests on a measurable difference between dry and frozen soil. Ice makes the material around it stiffer, allowing seismic vibrations to travel 2 or 3 times faster than they move through the dry soil. Ice-rich regions may also reflect seismic energy instead of allowing it to continue through the ground, producing an effect similar to sound echoing from a wall.
According to Schmer, a properly positioned lunar seismometer could record both signatures. Quote, we can use seismic waves to not just see whether ice is present, but also roughly how much of it is there, he explained.
The researchers tested the idea through 3 complementary approaches. Lead author Harrison Elizabeth, who's a PhD, looks like what, 2016,
yeah.
In geology, a UMD graduate and rock physicist at Lawrence Berkeley National Laboratory, began with a volcanic rock from Arizona that closely resembles moon dust when crushed.
Okay, what you made that up, Scott? What is a rock physicist? You made that up. Tell me.
I believe it. I would usually call that a geologist, but maybe they're a geologist on steroids. Not literally, but just
physics is like like gravity and that kind of stuff, and the laws of Newton.
Okay, yeah, I'm just thinking a geologist that's taken it to a higher level. So, but
okay,
yeah, I'm good for Harrison. This is cool that he's doing this.
Dr. Elizabeth froze the material, then used X-rays to observe how ice collected within the microscopic openings between its grains. This experiment helped establish how frozen lunar soil might be structured below the surface.
Co-author Matthew Siegler of the University of Hawaii created detailed temperature models of the moon's south polar region. The maps identify craters that have remained cold enough to preserve ice for billions of years. That's billion with a B, folks. That's a long time.
Yes. At UMD, Schmer simulated small moonquakes traveling through deposits of buried lunar ice. Now this is simulation. Across the laboratory work, temperature modeling, and computer simulations, the presence of ice produced clear, measurable changes in the seismic signals.
Ice on the moon could provide more than supplies for astronauts. Permanently shadowed craters can capture and freeze volatile substances such as water, preserving them with little disturbance over immense spans of time.
I didn't know water was a volatile substance. Maybe if it's rushing rapidly, yeah, I guess, like from a flood. Because some lunar rocks are roughly 4 billion years old, ice trapped among them may retain evidence from the early history of the solar system. Examining those deposits could help scientists investigate how water reached the inner planets.
Quote, the moon witnessed some of the most critical parts of the early solar system, including how water was delivered, Schmer said. Going on with the quote, studying the ice deposited there could reveal how water spread and ultimately how Earth's oceans formed. Well, I don't know about that. But anyway.
Future lunar missions may soon provide the first opportunity to search for the predicted seismic patterns. China's Chang'e 7, now we talked about Chang'e 6 the other day. Chang'e 7 mission is expected to land near Shackleton Crater in late 2026 with a seismometer on board. Several suspected ice deposits are located nearby.
Okay, so no manned landing, just
I don't know. It didn't say that.
Yeah, okay.
It says it's expected to land.
Yeah. Okay. We'll wait on further reports of that. Okay, so NASA's Artemis astronauts may follow in 2028 by deploying the Lunar Environmental Monitoring Station, an instrument Schmer developed or helped develop for seismic exploration. Data from these instruments could show whether natural lunar vibrations revealed buried ice in the way the researchers anticipate.
Quote, our findings are laying the groundwork for an observation we'll get in the next couple of years, Schmer said. No one has physically measured the ice on the moon yet, but we now have a prediction for what to look out for. That's an important first step.
Yeah. Okay. I believe
we talked about this ice on the moon being necessary to get onto other planets.
Yeah. I would think the next one would be the red planet, right? Mars. So
I hope Chang'e 7 can find ice. I really do.
Yeah. But with their machines.
Yep. Or with humans, with Chinese people. The Chinese people.
Okay.
Thanks, folks.
Take care, everyone. We'll see you tomorrow.
We'll catch you tomorrow. Yep.